Hello grade 11 students. In this video we're going to continue with our chapter talking about genetics, and in specific we're going to continue with the pedigree. So let's start with this question. Question 1. The following pedigree corresponds to a family where some members they are affected by the color blindness disease. This is the family pedigree. This pedigree shows that the red color represent the color blinded individuals, whereas the white they represent the normal individuals. Here 1 and 2 they are normal, but they gave birth to 3 and 4 that are affected. So the allele of the disease it's recessive with respect to the normal allele, which is dominant. Also 5 and 6 they gave birth to an affected son, 7. So the allele was masked in the parent. It's recessive with respect to the normal dominant allele. For example, let's say we gave N capital for the normal. So here in the pedigree, N capital for the normal. So this one should has N, and this should has N. 5 has N, and 6 has N. Why? They gave birth to an affected individual, 3 and 4, couples 1 and 2. Let's give N for the normal and C small for the color blindness. So here N and N. So here 3, 4, they should be homozygous, having genotype C small, C small. And 4 also C small, C small. And also the 7 should be C small, C small. So 3 and 4, they have CC. So they should inherit C from each of their parent, who should be NC and C. They should be heterozygous. Also 7 should inherit C from 5 and 6, and they should be heterozygous. 8 is the fetus. We don't know the genotype of this or the phenotype as well. So they want you to indicate the dominant and recessive allele. Justify your answer. Give the symbols or designate by symbols each of the studied alleles. Specify the genotype of the members of this family. So here specify, you have to justify, except for the fetus. So all of them, unless the fetus already, we solved them in the pedigree. Carry out the essential factorial analysis to predict the risk in the ratio form. So you have to work in ratio, proportion, for the fetus to be blind. So you have to calculate the risk for the fetus to be blind. So first, the normal allele is the dominant over the allele of the color blindness, which is recessive. Why? 1 and 2 they are normal, but they gave birth to color blind children, 3 and 4. So they carry the allele of the disease, but it was masked by the normal allele. Let N capital be the symbol of the normal allele, which is dominant over the recessive color blindness allele, and let C small be the symbol of the color blindness allele, which is recessive with respect to the dominant normal allele. Part 3, they want you to specify the genotypes. 1 and 2, 5 and 6, we can work with them together, but you have to specify. Parents 1 and 2 and 5 and 6, they're normal. So they gave birth to 3 and 4 and 7 respectively. What does it mean? This means that 1 and 2, they gave birth to 3 and 4, while 5 and 6, they gave birth to 7 respectively. So these parents, they must be carrying the allele of the disease, but it was masked in the parents. So it's recessive with respect to the normal dominant allele. So they should be hybrid heterozygous. However, 3, 4, and 7, they are color blinded. So they are homozygous, having genotype CC. So here it should be expressed only in the case of homozygous. 4. Carry out the essential factorial analysis to predict the risk for the fetus to be blind, and they want it in ratio form. So I have to start phenotype. They are both of them, they are normal. The parents 5 and 6. So 5 and 6 they are normal, and both of them they are heterozygous and C. So let's start step by step. Phenotype of the parents, male cross female. Both of them they are normal, the male and the female. So normal crossed with normal. Then we move to the genotype. For the male it's NC, and for the female it's also NC. Gametes symbol gamma, N and C. We have two types of gametes, and here we have N and C. So they wanted the proportion or ratio. So 1 over 2, 1 over 2, here 1 over 2, 1 over 2. Let's move to the table of cross, and then we will move to the table of results. So this table of cross, we're going to divide it into male and female, male and female, and we can divide this box into 2 and this box into 2. So here we have N, here we have C, half, half, N, C, half, and half. So N, it will be 1 over 4, NC, it will be 1 over 4, also NC, 1 over 4, and CC, 1 over 4. Moving now to the table of results. In the table of results, what do we have? We have the genotype that will give the phenotype. So the genotype NN, it's 1 over 4. We don't have unless this one. NC, it's 1 over 4 plus 1 over 4, it's 1 over 2. And CC, it's 1 over 4. So here, 3 over 4, normal. And 1 over 4, it's affected or it has color blinded. So here, the risk for the fetus to be colorblind is 1 over 4. Moving now to question 2. Question 2 talking about the blood groups. So the above pedigree shows the blood groups of the members of certain family. The gene coding for the blood group is found on chromosome 9. So this chromosome 9, it's the autosome. So this transmission, it's autosomal. While if it's found on the X or on the Y, it will be gonosomal. So here 1 and 2, they are individuals having the 1 and 2 having blood group A, blood group B, while individual 3, 4, 5, and 6 having A, O, AB, and the fetus 6 having the NA blood group. We don't know the blood group unknown. So here, let's start step by step. A and B. A and B, both of them, they individual 1, individual 2. Their offspring 3, 4, and 5. Here we have AB. So both of them, they are expressed. So this is the case of codominance. However, we have here allele O, blood group O. It was masked in the parent. So here the blood group A, it has genotype A, O. And here it has B, O. That's why here we have OO, since the O is the recessive. While here individual blood group A, necessarily it will be A, will get the A from the father, and from the mother, if it gets B, it will be AB, so it will get O, so it's AO. While here, it gets A from the father and B from the mother, so it should be AB. So is the transmission of the blood group autosomal or gonosomal? So here, autosomal or gonosomal, sure, it's going to be autosomal, since it's found on chromosome pair number 9. Second question, specify the dominant and the recessive. Allele A and B, they are dominant over the allele O, which is recessive, while they are codominant together. Why? Parents having blood group A and B, they gave birth to 4 of blood group O. So the parents might be carry the allele O, but it was masked by the alleles A and B respectively in the parents. So allele A and B, they are dominant over the allele O, which is recessive. Moreover, they gave birth to child 5 having blood group AB. So both alleles, they are co-expressed. So this is the case of co-dominance. Now we're going to move to perform the essential factorial analysis to predict the risk of fetus B6 to have blood group A, B. So what is the risk? Let's start step by step for the phenotype of the parents. These are the steps of the factorial analysis. Phenotype, male cross female. So phenotype of the parent, the male has blood group A. So you can put it this is the phenotype. And this is blood group B for the female. Genotype for the male and for the female. So the male has genotype A and has the allele O. And here we have B and has the allele O. So here we have AO and BO. Let's continue now for the gametes. In the gametes of simple gamma, we have 2 gametes in the male and 2 gametes in the female. So A, O. Here we want to work either percentage or proportion. So they didn't mention in the question. So here, essential factorial analysis, you can work percentage or proportion. We're going to work it proportion. So 1 over 2, 1 over 2. Here we have B and O, 1 over 2 and 1 over 2. Let's move to the table of cross. Let's draw the table of cross here. So let's divide it into male and female. Let's divide this into 2 and divide this into 2. Here we have male, it has A half, O it's half. Here we have B, it's half, and O small, it's half. So A, B, it's 1 over 4. B, O, it's 1 over 4. A, O, it's 1 over 4. And this B, O, the second and third one, O, O, it's 1 over 4. So if you want to move to the table of results, we have AB, it's 1 over 4, BO, 1 over 4. So let's move it, and OO, 1 over 4, and AO, 1 over 4. So table of results, we can divide it into genotype and phenotype. So genotype and the phenotype. So 1 over 4 AB, 1 over 4 AO, 1 over 4 BO, and 1 over 4 OO. So here they have 1 over 4, the risk to have blood group AB, 1 over 4 to have blood group A. Why it's blood group A? Because A is dominant over the O. 1 over 4 blood group B, and 1 over 4 blood group what? Blood group O. So the risk for the fetus to have blood group AB, risk for fetus to be blood group AB, AB is 1 over